Hello guys, welcome to the channel, and today I'm going to be showing you all how I made this orbiting projectile in Godot. So as you can see, this projectile is orbiting the player. It orbits the player even when the player moves. So I'll be showing you all how to implement this, and I've also made a 2D version of this. I'll be going over both, but you can skip through the video if you want the 3D version. So let's get right into it. First, I'll be explaining how both of these work. Let's imagine the circle, right? This is the path that we want the projectile to follow. And the center of this circle is the player. So to find any of the positions here or here, we need the x and y value of the position. And if we join this point and this point, we get a right triangle with the hypotenuse as the radius. And we know the radius of the circle. We just have to find the x and y value at any given point in time. Let me just draw a triangle real quick. So this is the triangle, and this point at any given point in time is the position of our orbiting projectile. If at one second it's here, then at the next second it will be here, and then here, and then here. And you can see the triangle also change. And we need the x and y coordinates, like I said. Consider this angle right here to be theta. So the sine of theta is the y-axis coordinate of the point that we want to find by the radius, which is constant and known. So the radius of the circle will not change, but as time progresses, the y value will increase and increase as it reaches the peak, and then the y value decreases, right? And same for the x value. The x value will be maximum here, and then will decrease, 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 0, and then will reach negative and max here. So the cos of the angle is the adjacent by hypotenuse. So x, y, r. So if we want to find x and y at any point in time, then we can just say x is equal to cos theta into r and y is equal to sine theta into r. So with this, we can find x and y at any point. And if you still don't understand, just try to visualize this. Let this be a triangle, and this is the point of our projectile, and this is the radius. As time moves on, you can see that the vertical part of the point is increasing, and the horizontal point is decreasing. But the radius is the same because the radius of a circle is constant. So it keeps going like this, and then it becomes 0, and then goes the other side. You get what I mean. And we just have to find the x and y values. So we use the sine and cos functions to do that. So I'm going to be showing you all how to implement this in the actual engine and how to make the projectile. We start making the projectile. I'm going to be showing you what I have set up here. We have a root node world and everything, and then we have a player with basic movement. This is just the most simple movement just for demonstration. So if we run this, you can see that the player has basic movement implemented, and that's about it. The player is also been given a group called player. This will be used to reference the player in the enemy script. We can start creating the projectile, or I'm going to be referring to it as the enemy because that's how I've named it. Okay, this is our projectile, or as I'm going to be calling it from now, enemy, and it just has a sprite 2D and an empty script. So we're going to open the script and we're going to start making what I just explained. First, we need a reference to the players. So I'm just going to make that. So as you can see, since the player has been given the group, the enemy will be able to reference it and will be able to orbit around the player. So now we're going to be creating a few variables for the radius, speed and direction of movement which the user can assign. So I think around 200 will be fine. And then these are all just experimental values, so feel free to change it up. And the direction is just gonna be a +1 or -1. So if you multiply it with -1, you're gonna be able to make the projectile move the opposite direction. Next, we're gonna jump straight to physics process. So to explain this better, I'm going to first make the enemy revolve around the origin. So all we're gonna do is we're gonna set the position to a vector 2, and this is gonna have the x coordinate and y coordinate which we just explained. So as I explained previously, the x coordinate will be the radius into the cos of the angle and radius into sine of the angle. Now you might be wondering, what is this angle value here and how is that gonna make the projectile move around the player? And it's pretty simple. In the example which I used to explain, we were finding the position using the angle. Here, we can assign the angle. So all we do is we keep increasing the angle from 0 to 360 and beyond so that the projectile keeps revolving around the player. So all we're going to do is we're going to add it with delta so that it keeps increasing every frame. And this is where the speed variable comes in and the direction. So the speed is just how fast the angle increases and the direction is just plus or minus. That's fine. And this should be it. So if I try to run it, you can see that the enemy is rotating around the origin, but not around the player. So how can we fix this? Well, the fix is actually insanely simple. All you have to do is add the player's position, which we have referenced on top, with this position that we find out. So if you run the script, you can see that the enemy just orbits around the player. Now, you can have more implications with this. The best part about this method is that you can gradually reduce the radius and make the projectile come closer and closer to the player. And I'll just show that right now. You can see that the enemy has gone, and then you can make it go further away. You can make it come closer. You can do all sorts of stuff. It's getting slowly further away, and then you can make it come slowly close to the player. And you can also do other stuff like increase the speed and change the direction. Now, one thing to note about this method is that the speed here does not depend on the radius. So, let's say it takes 1 second to complete a rotation with this radius. It's going to take the same 1 second to complete a rotation even with a larger radius. So you can see that it has increased its speed to compensate for it. So that's one drawback you could say of this method, but it shouldn't matter much as long as your game is not that complicated. Now we're going to be doing the same thing but in 3D. The setup is similar to 2D, so I have a player with a collision shape and the movement is as simple as it gets. So I'm just going to show you the scene once and that's about it. We're going to be adding the projectile. So this is going to be the projectile that's going to follow our player and orbit around him. So it has a collision shape and mesh instance, and we're going to be jumping straight into it. So first thing we're going to do is, just like last time, we're going to be referencing the player. And similarly, the player here also is in the group. You can obviously use your own methods to get a reference to the player. And we're going to make the variables for the radius the direction, and the speed. And we're also going to be making the angle, of course. Now the process is pretty similar to 2D, but we also have a third axis to consider. And in the case of 3D, the third axis is the y-axis. And here's the thing, we don't want the projectile to move along the y-axis. We only want it to move along the x and z-axis. So what we do is we keep the y-axis a constant and we move it along the x and z-axis. So you could have this constant be an export variable, but to make it simpler, I'm going to make it an already variable which takes the y-axis position of the enemy at the start of the scene so that I can just place the enemy how high I want it to be from the ground. We are almost done, so all we have to do is get the angle, speed into direction into delta. So if you don't multiply by delta, then the speed of your projectile will vary on the frames that the user is using. So it's always good practice to multiply with delta. And we'll just be setting the position. Now directly use your dot position here. And this time we're going to be using a vector 3 radius into cos of the angle. This is going to be the height, and then this is going to be the radius sine of the angle. And if we run the game, I forgot to add the enemy. And I'm going to be just placing it somewhere. The x and z position of your enemies don't matter in the 2D or 3D, but for the 3D one, your y-axis position matters. So if you place the enemy here, it's going to keep rotating at the side. And if you place it here, it's going to start rotating at the side. So I just run the game. You can see that it's rotating around, and sometimes it might look like the enemy is slowing down or something, but that's just because the player is also moving and the camera is constant. If I move this down, you can see that the enemy is much closer to the ground. Now if I move this up, you can see that the enemy is much closer to the sky. And that's about it. Thank you all for watching. If you do like it, make sure to like the video and subscribe as usual because more tutorials are on the way. And yeah, I hope you all found it helpful and I hope you all enjoyed it. Do leave any feedback you have in the comments because I am not sure if this is the easiest way to go about this, but this is the way I found. And I'll catch you guys in the next one. Peace.